Go.
Game on. Alright, so define, add, subtract, scalar multiplication, matrix multiplication, and the inverse, matrices. So not matrices, matrices. So if you say matrices, I'll know what you're talking about. Cool, so how many of you had already worked with matrices a tiny little bit? 1, 2, tiny, no? Cool. How would you describe a matrix?
Like the layout?
Yep, sure.
Like an X amount of number set inside of, like,
Inside of
hard brackets.
hard brackets, okay.
2D array of numbers.
Oh, a 2D array of numbers, that was pretty good. Okay. How was that? I like that.
Nah, mine was better.
2D array of numbers. That will suffice for what we're going to do. That'll suffice.
Solid.
Technically, it doesn't have to be 2D. Technically, it doesn't have to be numbers, but yeah, they are arrays. Can't think of anything that's not an array. It's a matrix. Yeah. That was actually quite nice. Well done. All right. So, overwhelmingly, this thing becomes, well, until we get to matrix multiplying and inversing, this is really, really boringly straightforward for the first bit, and then all of a sudden, it just veers off in a wild direction. So we'll do the easy bit, and everyone will be like, oh, yeah, this is easy. Then we'll do the next bit, you'll be like, wait, what? Okay. So for single variables, so like 2x plus y equals 7 or whatever, normally you have lowercase x and y. When you have matrices, you typically have capitals. So I'm going to define a matrix. 1, 2, 3, 4. Cool. And we'll make the matrix B. 5, 6, 7, 8. Matrix C, D. 2. So we need to cover a couple of ideas about this. Are these the same in any way?
Some of them
Some of them.
share common values.
Okay, they share some common values, yeah, true. Is there anything, okay, sorry, let me rephrase that. For A and B, is there anything the same?
The way it's laid out.
Say again?
Yeah, got 4 numbers in it.
Okay, they've both got 4 values in them, yep. And it's so obvious that you're overlooking it.
It's
Yep.
square.
Right, it's square, right? It's 2 by 2, right? So this thing, 2 by 2, this thing is also 2 by 2. Cool, taking a look at this guy.
1 by 2?
Okay, so it's got to be 1 by 2 or 2 by 1, yeah?
Yeah.
And so irritatingly, 2 by 1.
Oh, okay.
You always read down then across the next.
Makes sense.
Cool. I don't know if that does make sense, to be honest. It just is. That's just the way it got defined.
I mean, I feel like it's easy to read downwards, like with numbers, like instead of across.
Sure.
It's like maybe you might
It's
get
arbitrary. It's just that
bamboozled.
one, go down first, then go across. That's just the way that it is. Cool. So these things, these are called the order of the matrix. So it's order 2 by 3. Or, yeah. Great. So now we do some very boring things for a second. The matrix A plus B. Okay, any thoughts on what we will probably end up with?
6, 8, 10, 12.
Right, so end up with 1 plus 5 there.
6.
6. We'll do some blue actually, so this is something we're calculating. So we have 6,
8, 10, 12.
and 12.
Sweet.
Cool, we're all happy about what just happened?
Mm-hmm.
Yep. Do you want me to run through subtraction? No, right, it's such a waste of time, right? Addition and subtraction, very, very boring.
What is subtraction?
Subtract minusing.
I'm joking.
Oh, okay, right.
Sorry.
You're right. Let's go 3B. Take a guess.
15, 18, 21, 24. 18, 21, 24.
Beautiful. Cool. is this like so boring that like why am I wasting your time?
Well, currently.
Uh,
I mean, it's good knowledge. Great to know, sort of assume.
Okay, good question. Now we're actually going to start doing annoying things. Is that right? 17, 17. Cool. So Aaron has asked a good question. What happens if I do A plus C?
Would it just be...
Oh, did you? Okay, come on. Okay, I'm going to say A and C.
So it's just all of them.
Would it just be 2, 2, 5, 4?
Okay, so
So from
2,
5, 4.
5, 4. That's what we say.
Yeah, that's what I would say.
Cool. That makes a bit of sense. Yeah.
But it's wrong.
No. Of course that's not.
Of course it is.
Would it be 2, 3, 5, 6?
Does not exist.
Ah, lol. Haha.
It's even more simple than you were allowing for, right?
They did not exist.
Are they the same size? Are they the same order? No, it doesn't exist.
So
Ah, okay,
And
cool.
minus things that don't exist.
So that's
Sorry,
similar
don't
to,
have the same order.
so similar to like say like terms.
Yeah, sort of. Sure. Except that if you don't have like, if you have x plus y, it's still x plus y. If you have a plus c here, it's just like, that's a nonsensical statement. It's like saying apple plus orange. What?
But that's still technically x plus y, because you've got an apple
No, you
plus
can have
y.
an apple and an orange, but if I say apple times orange,
Ah, true.
what does that even mean? It doesn't mean anything. So same thing, a plus c here is just, it's a nonsensical statement, does not exist as a result. Cool. Right, unsurprisingly, you do any other mixed match, they're not going to result in anything.
So C and D wouldn't do anything either.
C and D do nothing. Alright, so we'll just make that explicit. Cool, does not exist, we're done. Cool.
Sweet as.
So that's that. Cool. This thing is called scalar multiplying.
Solid.
Right? Take a guess. Why? Right, you're just scaling the whole thing by a factor of 3. Yeah, sorry. Hence scalar multiplication.
Oh, what's matrix multiplier?
Ah, I'm so glad you asked. Almost as though it leads you onto this. Still inception. Okay. Alright. So let's go. This is going to annoy the hell out of you.
Challenge accepted.
I'll give you this result, and then you're going to go, how the hell did that happen?
Oh my god, is it like... Yeah, is it 1 times 2 times 3 times 4 times 5?
I'm trying to think.
No, it's not.
Oh wait, no, there's one more. This is. No, that's right. Can't hold this many numbers in my short-term memory, that's worrying. Okay, so can we make any sense of that whatsoever?
Yes.
Yeah, go on.
17, 24, 43 and 50.
What?
That's about all I got.
What do you got? What was that?
Literally nothing.
Oh, okay, alright. Cool. So, is this obvious and well defined? No, it is well defined in the end when you know how it happens, but this just looks like garbage, right? You're just throwing some things together and something totally different came out. What the hell's going on? So, there is a complicated way of doing this that for some reason every textbook teaches you, and I have no idea why. When I teach you this easy way, you'll be like, I'll do that. So,
Why don't you just teach us that way then?
that's what I'm going to do.
Ah, okay. I thought you were giving us the garbage one.
Okay. You don't do this in your head for a start.
Aww.
So A times B, the way we're going to think about this, whatever the first one is, goes slightly below. 1, 2, 3, 4. Ooh. Whatever the second one is, goes to the top right of that.
Okay, solid.
This is just the setup. You go to whichever position you want to fill in, which is going to be here for now. Cool.
But 17's a
From there,
prime
go as
number.
far away from it as you can in a straight line. So all the way out here. 1 times 5.
5.
Move in.
Ah,
This times this.
14.
14. And apparently I can't add. Good.
Same problem.
So that's there. Cool. I've now moved inside, and you should move inside simultaneously.
Yeah.
Right, so I've gone out, gone all the way out,
Oh, yeah.
then these 2 times together, and I'm adding those results.
Ah.
Cool. I now want to do this position.
Oh, I get it.
So 6 times 1 and then 6 times, 8 times 2
Right.
and add them together.
As far away as you can. 6 and 1
6.
plus.
32.
16, yes, good
I've
maths.
moved inside, I'm done.
That's 22.
Oh, Jesus. This is why you don't do it in your head.
Good play.
Alright. We'll go here, go as far away as we can.
3 times 5 is 15.
Cool, move one in.
24. 28. Shit.
Hey, hopefully. I get that one right.
Hey, you can't say anything.
30, 40, there we go.
Wait, 7 times 5, 30, 7 times
7 times 4, my
Right
go.
here, 5 and 3.
15 and 20. Ah.
This is garbage.
So we want this last position, as far away as we can.
And 32. Oh, I don't like any of this.
I love it.
Good, you're normal, you're human.
Is this the easy method?
Yep.
How do you work out the hard method?
Yeah.
I'll write it out in a second.
Yeah.
Write it out. Oh my god.
What are we on, 22?
Yeah. 43 and 50.
That's
You wrote it up above.
Oh yeah, I did tell. Cool, so it simplifies down. That's the neatest method that I can give you.
And that's the final answer.
That's your, yeah, that is what A times B is. Cool. Alright, if you want the more complicated one, I'll write that out now.
I don't want it, but let's have a look.
Let's see how bad it is.
Where is it? Oh, they don't even have it in the book anymore.
Oh, okay.
How's it go thing?
No, but just decided not to, just at all.
Yeah. They used to, quite literally.
So now they just have this.
So if they had a, oops,
Oh, so I have a
Yep.
question.
Yep.
If there was A divided by B, do you have to do it on the top left corner?
you're asking a good question, TJ. We will very slowly get that. Okay, so that's supposed to be 2 2 by 2s, right?
Mm-hmm.
Then separate entry.
Was that being G?
Yeah. And next is. There you go, that's how you do it.
She's kind of
It's
dumb.
so easy to remember. No, right? Which is why I say set it up like this, so at least you've got geometry helping you. Whereas this is just garbage.
That makes sense.
It's the exact same thing as what we did. That makes sense? That makes sense to you? As in,
Well, I mean, it's just the left
equals
side.
this,
The
makes
left,
sense.
the
Not
left
you can
side.
follow it, but this makes sense to equal that.
Yeah.
After looking at that, it does.
Yeah, after, okay, yeah. After looking at this, yeah. But before that, not so much.
But
Anyway,
it's just the left side multiplied by the top side, added by
Yeah.
the right side of the first one, multiplied by the bottom one.
right, well, I should do that if you're multiplying 2 things.
I was looking at A
Yeah.
plus 3 geometry, A times A plus 3 times
It
J.
just seems like an arbitrarily defined thing, and it does have good reason for everything, but that is so far beyond this course that this is just taken as this is the thing,
Just take
we're
it.
just going to do it.
Maybe this is.
Okay, so we've got that, great. Now, I've got this, what's it going to be?
So it's
The
just
same thing.
Yeah,
Well, the same
No.
thing would make perfect sense, right?
But it's probably not.
Let's check it, just in case.
No, it's not because it'd be. Wait, yeah. Surely.
The numbers here.
This position,
Oh no, it's no.
first number,
5,
next number,
15.
Try again.
Wait, what? Oh, 6
18.
times 3, so 18.
18.
So I did 5 times 3.
Cool. This position.
Yeah.
10,
20,
24,
7,
What's up?
6,
21.
21. So
Because the numbers are in a set.
Oh, 8 times 3, I keep forgetting 24. So, 14 plus 32,
Whatever this is.
23, 34. Yeah, that.
Cool. Are they the same?
No.
So we get the first really irritating result.
Just not equal.
Is that really unfortunate?
Just
Yes, because it means half your instincts are going to be wrong.
annoying.
Oh, what? Wait, would that make. Oh, no.
What's the point of this?
It allows you to do really big calculations quicker if you're doing it by hand. But it gives you another way of thinking about things. We will get to that eventually, but for now, this is very much why do we have to do graphs like y equals mx plus c? Why did you have to do that in year 9?
Because we did.
I've been asking
What
myself
would
that
they
question
use
for like my entire
What would
life.
they become useful for?
Why?
Now, okay, well, okay, granted.
Why not do that?
I'm sitting on year 6,
Are there
like, why?
certain scenarios that you can go from words into graphs with?
Yes.
Yeah, right. Is it easier to make predictions from the words or from the graphs?
Perhaps.
Right. So the whole point of this is going to be eventually it makes something easier later.
Can we get a graph?
So we do graph things with these
Oh,
eventually, graphical transformations, but we'll work our way to it, or matrix transformations, I should say. Cool. So that's our first annoying result. So that's matrix multiplication. Brilliant. Cool. Next thing.
Oh, what? Surely that can't be right.
Right, this shouldn't exist now,
Oh,
right?
No, it can.
Okay, so we set it up. 1, 2, 3, 4.
5, 6,
Oh, beautiful. Okay, I go from here.
3,
I go from there.
4.
6, 8.
Cool. Brilliant. So now I've started off with a
2 by 1.
2 by 1 and a 1 by 2 and ended up with a 2 by 2.
That makes sense.
Does it? Okay.
Well,
That makes sense.
if you just multiply them together.
Yeah. Oh. That's just.
Oh, yeah, a lot.
Does that what?
Oh, is that what you did?
Is that it?
That's a 1 by 1.
So
Like
now I
what?
started off with a 1 by 2 and a 2 by 1 and ended up with a 1 by 1. Does that make sense?
No.
Yes. Somehow.
You can follow it. But
I mean, it
is
kind
it
of, yeah.
intuitive? No, probably not.
You could, I mean, you could look at the 2 by 1 and.
possible to have
Is it possible to have
two different separate brackets?
different separate, right? You mean matrices or?
Yeah.
Yeah. Okay, just matrix times weight on the matrix.
So where would you put it?
Wait. Then I don't think I understood your question. Say again.
Like you just put it underneath. Oh wait, no.
So I'm saying the matrix D times C is the matrix with just
Oh,
a
did you see
single
that?
entry 11.
Did you see 3 plus 8 and 11? I think they were 2 different ones.
Yeah,
Oh,
sorry. This
joke, yeah, that's
is
what I
one
thought.
thing which is equivalent to that.
I thought it was 38 or something. What the hell?
3 plus 8. Okay, cool. Alright, let's add in a new matrix. Matrix E.
7, 9, 12, 11.
Calm down. 5,
4,
6,
4,
7.
4. Oh.
Oh, cool.
Honestly, no original. Quite
Go
Let's go.
C times A.
Alright,
Okay.
Oh.
1, 2,
5, 6, 7.
5, 6, 7.
Ah. Oh, damn, this is tricky.
I've got to start here. I've got to go as far away as possible. So that gives me 5. This one's moved inside, this one hasn't.
Just nothing.
Alright, has the method broken down?
Yeah.
So it's undefined.
Does not exist.
Does not exist.
Alright. She can't have or 2 by 1s multiplied by anything times 1. So like 2 by 1 can't multiply to 2 by 1.
I have a
Not
question.
quite. Yep.
Is it possible to have making 3 numbers?
3 by 3? Yeah, you can have 3. Let's make a number.
Not like a 3 by 3, but like in 1, 2, and then 3 on the bottom.
Oh, as in like that sort of shape?
Yeah.
No. They have to be rectangular.
Rectangular
Yeah,
or
zeros.
squared.
So you have like 1, 2, 3, 0, but then it's still got a value of 0 in there.
And that means that you can still do a 3 by 3. No, you can still do a 1 by 3 and a 3 by 1.
Yep. Or 3 by 2, 2 by 3, 27 by 56. Yeah, you can do whatever you want. Arbitrarily big, yeah.
But both of them will make different answers. So a 3 by 1 will make a different answer to 1 by 3.
A different.
Oh wait,
Depends what you mean by
if a
different
3 by 1 was times by 1 by 3, it'll be a different answer to if it was a 1 by 3 times a 3 by 1.
Right.
Okay.
So C times A does not exist. What if it was A times C? Would that also not exist?
Alright, well, let's think about it. Okay. I've got E times C.
You do have 8 times 3.
Alright. How's that going to work?
Put
I've
down
got
3
5, 6, 7 down this way. And I've got 1, 2 up that was terrible. 1, 2 up that way. I go as far away as I can. I get 5 and 1. This one's in, that one's not. Broken again.
Yeah. So
Doesn't exist.
yeah, that's what I was saying before. So like 2 by 1s can't multiply by or any other number times 1.
Okay. Let's make F 9.
Okay.
Just pick a number. Okay, if I do, so what did you say? 2 by 1, so C
Yeah.
can't multiply by anything that ends with a 1. 1, 2, 9. This-
Oh well, it doesn't go down. Yeah. So anything other than 1.
Right, so we need a general rule, right? Because sometimes this works, sometimes it doesn't, and we'd like to know what's going to work before we do anything. So, we'll write this out. I had a 2 by 2 multiplying by a 2 by 2. Cool. Here I had a 1 by 2 multiplying by a 2 by 1. Here I had a 3 by 1 multiplying by a...
It was 2 by 1,
No,
not
wait.
3
Oh,
by 1.
sorry, this way, sorry, I was looking at that. Sorry. 2 by 1 multiplying by a 3 by 1. Here I had a 3 by 1 multiplying by a 2 by 1. Here I had a 2 by 1 multiplying by a 1 by 1. And this one I got a result with a 2 by 2. This one I got a result of a 1 by 1. This one I got a result of nothing.
Can you rub that 1 by 1 out?
Rub the 1 by 1 out.
The 3 plus 8 brackets? That one? Yeah, can you rub that? Because that's confusing. Because I keep thinking there's 2 brackets here.
What?
There you go. Three plus 8. Yeah.
Okay.
Give you straight.
Just so that when someone looks at this later, they'll remember why it's 11.
Is C times X a 2 by 1 or all by 2?
This is a 3 by 1 and a 2 by 1. Is that what you're saying?
there's a 1 and a 2, it's just rather small.
Yeah, we'll move it. Awesome. There you go. Is that better?
I was thinking 1 by 2 and then a 2 by 1.
Count down first. Down first, then first. Cool. Anyone figured out what works and what doesn't?
If it's a divisible by 3, it does work.
Yeah.
Okay. If it's 6, doesn't work.
Cool.
That's a little one. What do that for?
Oh, okay.
Yeah.
Yep. If if it's the same number for how many times it'll work.
Oh, yeah, well.
Cool. So if it's the same things touching, right, then it will be defined. What shape will it be once it is defined? Whatever the outsides are.
Hey, what?
Oh, I get it.
So insides touching are the same, good,
Yep.
that means it will be defined. So the end result will be the outsides, 2 by 2.
Oh, okay.
Right? Not the same, won't be defined. Are the same, will be defined by the outside, 2 by 1.
Oh.
What if it's the same on the outsides but not on the insides?
Where was that? Did we have that? No, we didn't have that. No. Short version is, if this fails, then you're done. The insides have to be the same, regardless of what the outsides are.
Okay.
Beautiful. So that's matrix multiplication. That's all 7, whatever letter that is. E. 7F is the pain in the ass part that naturally comes next.
Do we have to do 7E if this all is really easy?
Yeah.
Are we gonna get
Wait,
homework?
wait, scale multiplication is just the adding.
No, scalar multiplication is when the whole thing just gets multiplied by.
Okay, good, because I totally forgot what it was.
Yeah. So that's
Cool.
Isn't that like you're putting like an expression inside brackets with the one outside?
Scalar. Does scalar multiplication, or is it only just multiple?
yeah, when you just multiply it by some number.
So what's a plus b?
That's matrix addition.
Okay.
What would it be if it was like 3 times a plus b, or a 3 times, in brackets, a times b? Would it just be the scalar of
It's the scalar of
the matrix
a
multiplication?
times b. Or alternatively, you can do 3a times b, but that's getting unnecessarily fiddly at this point. So yeah, some things will hold true, some don't. So, like na times b is equivalent to na times b. It's also the same as a times nb, but it's also
Is
equal
it?
to na cross b. All those are the same. Right, so that's like what you normally expect.
What does n stand for?
Just some number, like
Okay.
3 or whatever. Right. So that operates how you expect. A plus b is the same as b plus a. That operates as you expect.
A minus b.
Yeah, same thing. A minus b is. So,
No, but it's not equal to b minus a.
no, but it's equal to negative b plus a, which,
Makes sense.
yeah, that's how normally that would work. So those ones hold true. It's usually only with multiplication that you start getting into trouble.
And what
Sorry,
about
Matt.
What about division?
Thank you. I was waiting for someone to ask. Naturally, the next question becomes, how do we do division? Short answer is, you don't do it directly.
Alright, cool. Let's just scrap it and start again.
So if I said, what's 20 divided by a half? You
I would say
tell me
40.
40, right? Did you actually divide by half?
No,
What did you do?
multiply by 2.
Right, why?
Just keep
It
changing.
just makes sense. It's easier.
It's easier, right? Right, keep change flip is the short version of it, but why do you do that in the first place?
It's easier.
So,
She changes it into a multiple.
right, we know how to do multiplication. That's bad enough, right?
Yeah.
Division in matrices actually fundamentally isn't defined well, depending on what you do. So we need a way of dividing when we can't actually divide. So we're going to times by an
Yep.
inverse, right? Because when you had divide by a half, that was the same as multiply by 2.
So when you inverse when you inverse a 1 by 2, a 2 by 1, will it be a 1 by 2?
It's a good question, TJ. Let's find out.
On
So-
the next episode. Oh, joy of me.
Firstly, we're going to define this guy.
That's I.
That's I, right? Specifically I2.
It's a column. It's holding up.
Why I?
My rules will live.
Take a guess why I2.
Because iPad was taken.
I squared.
Not I squared.
No,
squared
it squares up the top. It's because there's an I1,
Oh.
otherwise known as I. Oh, it's because it's. So I1 would just be 1 by 1?
Yeah.
Oh.
What would it have in it?
It's just
one.
zeros.
1, right? So these are called identity matrices.
Identity.
Identity.
Identity. Identity.
is the answer why they're called identity matrices. Let's do I'll get you to run through that.
Identity.
Times A. Oh god.
That A way over there.
So you've got.
Identity.
Are we doing it? Oh, oh no! I thought we were doing it on the board.
No, do it on paper.
Identity.
TJ, you're gonna die a fatal death, buddy.
All good. Shot this way through.
Yeah.
No, lol, yeah.
Yeah. Now it's starting to make sense. Why it's called identity.
Oh.
Watch him pull out a 7. Seven, no way.
I2.
Wait, where's I1?
I1 is just 1.
Oh, thanks.
There you go.
So how did they like originate?
That is what.
Like why is it 1 0? Like why is that the format?
Because it's an identity by definition. Okay.
Well,
I'm done with this, or are we still going? No, we're still going. I've got to wait for them to
kind of did half of it, then I was like, yeah, okay, no, I'm done.
You already knew what I was going to do.
So you got to the end and then realised.
We'll have some minutes together.
What if there's three?
Go.
That's
We all
the
done? Yep. Yep. Alright, so hopefully you ended up
No, I didn't.
back
I did
with
the first
1,
line.
2, 3, 4.
I did one.
Yeah?
I did this
Cool.
line.
Why is
and
this
then
thing
I'm
called
like,
the
oh, okay,
identity matrix?
Because it's identity,
This is the
identical.
first, second.
Right, you end up back with
isn't it?
something. Right, you end up back at its own identity.
But I just did the first
Okay.
and second.
Wait, what happens if it's
I'm like, oh, cool.